Okay, let's get it started with this example here. So one more time, we are working on the examples problem on sampling distribution, right? In previous class, we already looked at the central limit theorem and sampling distribution. We saw three different cases. The first one is the sampling distribution when the sample size is greater than or equal to 30, right? That's the first case. Second case, when the sample size is any, but the population is normally distributed. And the third one is the sampling distribution for proportion. But there was a special case in that, that is if n times p and n times q is greater than or equal to 10, then the distribution of the proportion is normal, right? That is what we have seen. So based on that, we are going to look at few examples here. And this is our first example. You can see children between the ages of 3 and 7 watch an average of 27 hours of television per week. That is general information, right? Information about the population of children in that age group. They watch 27 hours of television per week. Okay. Assume the variables are normally distributed and the standard deviation is 4 hours. So up to here, they are trying to give the information about the population, right? In general, for the population, let me highlight that. For the population, average is 27 hours. That's your average. Okay. And also, they said that the variable is normally distributed. Meaning of that is population is normal. Okay. Normally distributed. And the standard deviation is 4 hours. Standard deviation is 4 hours. So meaning of that is here we have a normally distributed population where mean and standard deviation are given. And what we know is if the population is normally distributed and mean and standard deviation are given, then the sampling distribution of mean is also normal, right? That's what we know from central limit theorem. And here the question is, if 25 children between the age of 3 and 7 are normally selected, so you can see we have the sample size there, and the sample size is 25, n equal to 25 children in that age group are randomly selected. We have to find the probability that the mean number of hours they watch television is greater than 25. So here we are looking for probability that the mean or average is greater than 25 hours is how much? So this question is clearly giving you all the required information to tell you that the problem is based on the sampling distribution of sample mean, right? We have clear information about the population, which is normal. Mean and standard deviation are also given. And when you're looking at the probability, we want to find the probability of average. Okay, we are calculating the probability of average. When you're looking for the probability of average, we know that it is the sampling distribution of average or sampling distribution of mean. Okay, that's where we start. So with all that information, let's begin. Once you know those information, it's easy to follow up with the things. So, okay. So we have the information about population. We can write this. About the population, what we know is it's a normal population, normally distributed. Mean is equal to 27. And standard deviation is equal to 4. That is what we know. About the sample, we know the sample size. Sample size is 25. Right? Sample size is 25. We know that. And once we have this information, we can say that from central limit theorem, let's write this down. By central limit theorem, the sampling distribution of sample means is normal. That is what we know from the central limit theorem. The distribution of sample means will be normal. And for this normal distribution, we know the mean and the standard deviation, right? Mean for that is, okay, is normal with, let's write, with mean mu is equal to mu of, I can write like this, mean of the sample. So mu sub x bar is equal to population mean mu, which is 27, right? And the standard deviation, we write sigma sub x bar is equal to sigma over square root of n. Standard deviation of the population is 4 divided by the square root of 25. Sample size is 25. So that becomes 4/5 or 0.8. See, from the first part of the problem where we talk about the population, we know from there that the population is normal with mean and standard deviation given. So because of that, we know from central limit theorem, the distribution of the sample mean will be normal. And we have the formula to find the mean and the standard deviation for that normal distribution. And we got those two information. Okay. Once we have these two information about the distribution of sample means, what we do is we try to sketch the graph to represent this distribution. Okay. Let's do that. Let's sketch the graph for the distribution. Okay. Okay, here we go. So along the x-axis one more time, we have the mean or the average x bar. This one is normal distribution with the mean of mu sub x bar and standard deviation sigma sub x bar. We know mu sub x bar is 27, so we put that in the middle. Any questions so far? Okay. Now tell me, because we have this 27 here, we are looking for probability that x is greater than 25, right? Greater than 25. 27 is here in the middle, right? Where is 25? Is it on the left of 27 or right of 27? On the left. So we have to show that 27 on the left. Let's do that. Let's show that 27 there. 27 is already there. So 25 on the left. Okay, there we go. 25. Now, finally, we want the probability that x is more than 25. When we say more than 25, do we say it on the left or on the right? On the right. Okay, let's do that shading. Say it on the right. Okay, we do that shading like that. Then we can use calculator to find the probability. Now, probability that x is greater than 25 is equal to, now we are looking for probability. When we want probability or area, do we use normal CDF or inverse normal in our calculator? Normal CDF. Okay, let's do that. Normal CDF. Normal CDF. Because to find the area or the probability, we always use normal CDF. Then the lower boundary. What is the lower boundary for this area? Look at the diagram. 25. Upper boundary. It goes all the way to infinity. Okay, infinity. Mean is how much? 27. And standard deviation is 0.8. Very good. Now, please use your calculator and tell me what you'll get. Okay, what do we get? 1. Is it exactly 1? 999. Okay. Probably it's like 0.99, maybe 38. That's right. When you go to 4 decimal places, right? 0.9938. Almost one, almost everything. So one more time, you can see that this problem is based on the sampling distribution of sample means. Okay, that's why we have mean along the x-axis. We use the central limit theorem. We found the mean and the standard deviation. Use that information in the diagram, and we got the area or probability that the average number of hours they watch television per week is greater than 25 is 99%. So look like 99% of the children watch television for more than 25 hours per week. The children in that age group, according to that research. It's too much, right? Yeah. Okay. If you have any question on this one, let me know before we go to the next example. So this one was the example on the sampling distribution of sample mean. Okay, we did 2 different type of problems in the last class, but today we are doing just one from the mean and one from the proportion. Okay, so now is the time for, so this was the information on the sampling distribution of proportion. If you remember, if n times p and n times q is greater than 10, then the distribution of this proportion will be normal. And then for the mean, mu sub p hat is equal to population proportion p, and the standard deviation will be square root of pq over n. Okay, we already have that formula, so let's go to the example. I have the condition listed there, n times p, n times q greater than 10. Okay, here is our example. Suppose 57% of adults in US between 35 to 40 years of age exercise at least 4 days per week. So that is the information about the population. When they look at this age group, 35 to 40, 57% of the people, they exercise at least 4 times a week. If we take a random sample of 90 adults, now we are analyzing 90 adults in that age group, okay? We have to find what is the probability that more than 45% of them exercises at least 4 days per week. So here you can clearly see that the question is talking about percentage, right? Whenever we are talking about percentage, you know that we are talking about proportion. So this is the question based on the sampling distribution of proportion, okay? So about the population, you can see they have given the information about the population. 57% of them exercise at least 4 times, 57% of all adults. So P is equal to 0.57, right? P is equal to 0.57. Now, can you tell me if P is 0.57, what is Q equal to? That's right, Q equal to 0.43, because total percentage is 100. Out of 100, if we have 57 here, 57 who regularly exercises, then the other, they don't exercise 4 times a day, meaning they may exercise more than 4 or maybe less than 4, right? Not 4 times. So that is Q equal to 0.43, because 57 plus 43 makes 100% there. And then that's about the population. Now we are talking about the sample of size 90. You can see there, sample size is 90. Let me also highlight that. So that's your n equal to 90 in the same group. We have to find the probability. What is the probability? Okay, so we write like this. What is the probability that more than 45%, so we are talking about the proportion of the sample p hat greater than 0.45. 45% means 0.45. That's equal to how much? That is the question. So always remember, when you're working on the problem in statistics, you have to read the problem completely first. If you need to annotate like this, the way I'm doing, you can tell. Easy for you to pull the information as you work on them. Okay. So collect everything that is required there and then start working on it. So we know that this is the problem on the sampling distribution of proportion. So we want to check first n times p and n times q, whether it satisfies that condition or not. If the condition is not satisfied, we cannot solve the problem. Okay. We can solve only if the conditions are true. So let's check it. So here, n times p, n is 90 times p, p is 0.57. If you multiply this, what you'll get? You can multiply and check it. Is it 51.3? Which is greater than 10 again. N times q, if we do that, it's 90 times q is 0.43. Also multiply this in your calculator. It should be 38.7. And you can see that this is also greater than 10. So the conditions are true. And you know that if these two values are greater than 10, the sampling distribution of proportion is normal. That is what we know from our central limit theorem. So we can write by central limit theorem, the sampling distribution of proportions is normal. Okay, is normal. And if it is normal, we need to know their mean of the proportion and the standard deviation of the proportion. We want to know this. Mean of the proportion is equal to population proportion P, which is 0.57. And then the standard deviation is the square root of PQ over N. We plug in the value and simplify. P is 0.57. Q is 0.43. And the value of N is 90. You can type that in your calculator and then check it. I got 0.0522. Make sure you plug in the values in your calculator and check it. Same. Okay, good. That is good. So that means my calculation is correct, right? Okay, so once we know that it is a normal distribution, and when you know its mean and the standard deviation, it's time to draw the normal curve and represent that. So let's do it. Let's draw a normal curve and represent that. So let me draw a normal curve like that. Okay, so this is the normal distribution with the mean mu sub p hat and standard deviation sigma sub p hat. And the mean that goes in the middle is 0.57. And along the x-axis, we have the proportions p hat. Okay, we have everything ready now, right? We have the diagram. We have everything labeled. Now we can easily calculate the probability and answer our question. So the question here is, what is the probability that more than 45% of them exercise at least 4 days per week? So p hat greater than 0.45. That's what we want, right? Here we have 0.45. In the middle of this distribution, we have 0.57. So where is 0.45? Is it on the left of that or on the right? On the left. Okay, so let's represent that on the left. On the left, we have 0.45. 0.45. We also need to set the area to represent that probability. Okay, and here we want p hat greater than 0.45. So the numbers which are greater than 0.45, are they on the left or on the right? Right. So we say it on the right. Okay. So let's set it on the right. Okay, once we set it and make it ready, now we can find that probability. Now, probability that P hat is greater than 0.45 is equal to, what do we use? Normal CDF or inverse normal? Normal CDF. Okay. Normal CDF. Because for area or probability, we use that. And then we start with the lower boundary. What is the lower boundary for the area? 0.45. What is the upper boundary? Infinity, mean 0.57, and standard deviation is 0.0522. Very good. Now you have to type that in your calculator and find the probability. Please type it in your calculator. Point 9892. Okay. 0.9892. Make sure you type that and then check it, everybody. Okay, any question on this example? Is this the last example? Okay, so the